Now, to close for our final presentation, yeah, because he was ready there, but then I need to take some time then. So it's we're going to see a small investigation into what is a possible attempt at an hijack from Lasse.
Yes.
Yes, does it work?
Thank you. I put a question mark there at the end because, well, like Alexei, I really don't know. So you be the judge of this. So we've seen this. I want to show you what we've seen, and my question to you is: was this a BGP hijack supposed to happen if we haven't caught it, or was this just some random event? I don't know, but you be the judge. At least, by the very least, this was an improper use of AS sets. So what actually happened? Our very good cooperation with our IP transit provider caused them to alert us, and thank you, Ricard, that someone had created an AS set in the RIPE database referencing our AS number. And anyone can actually do this. So going into IRR Explorer from NLNOG, we saw that these guys, apart from their own AS, they had included our AS in the AS set. And an AS set would be used to sort of make a collection of ASs that has some shared property. And we were thinking, what is the shared property here? So looking into this, these are apparently, well, BGP tools say they are from Russia. And basically, I'm sorry, do I know you? What is all this about? So we looked into that, and well, their country code says they're from Russia. Their address is somewhere in Tehran, Iran. So no, definitely we are not connected to you in any way. Additionally, in their routing policy that they published, they were using this AS set with our AS number included, saying that they would announce this to a tier 1 transit provider. So looking just at the routing registry, which is not BGP, they are saying, yes, we will announce Talia's AS number. No, you will not. So why is this a problem? Because obviously this is just in the RIPE database, and as we know, the RIPE database contains lots of stuff. But what is actually an AS set? Well, an AS set can be used. It's basically just a list of ASs. And you put that list into the RIPE database saying, this is a list of ASs that I want you to know about. And they can be used for anything. It can be ASs that are present at this internet exchange point. It can be ASs that I peer with somehow. Or it can be ASs who the salespeople were out drinking beer with last night. Whatever you want can be an AS set. And I know Lasse wants the last one. But the most common recommended usage of an AS set is to communicate to your IP transit providers. These are the list of ASs that I will be announcing. And so this, I've included an example from Manners, who have a very excellent course on how you do proper filtering on the internet. And a very important part of filtering on the internet is that you filter your customers and what your customers announce to you. All tier 1 operators will do this somehow and with automated tools, and it is all based on AS sets, route objects, etc. in the RIPE database. So this is just an example courseware on how you would properly go around to doing that. But so what is actually the problem with them including our AS in their AS set? Because we are obviously not connected to them, whether they are in Iran or in Russia or anything. Well, this, in my opinion, is a setup to start spoofing our AS set. So it's very, very easy to just configure a router on your own network and use our AS number. And you can announce this in BGP. And normally, if you just want to spoof and do a normal BGP prefix hijacking, well, you type this IP address prefix that you don't own, and then RPKI will save you because it will not be valid, and then it will be filtered out. But if you also announce using the correct route origin, the origin AS, then suddenly the ROA match, but you're not actually the owner of that AS. So other than having a valid ROA, then the tier ones would on top of that have the RPSL-based filtering. So filtering based on what is in the IRR databases. And this is usually today what saves you from BGP hijacks that are also spoofing your AS number. But when anyone, and anyone can just put your AS number inside their AS set for any whatever reason that they want, then you basically open yourself up to this, where they say, I will, to my IP transit provider, announce this set of ASs with completely fraudulent entries in it. And well, then we're directly connected to our upstream provider, and that is a tier 1 provider. So yes, now they can spoof our IP addresses, they can spoof our AS number, and suddenly we will have over at the other tier 1 provider an equal AS path length, and they might even be able to attract some of the traffic that should be going to our network. And this is exactly what we don't want to happen, what RPKI was supposed to save us from, but in this type of corner cases, it does not. So what can we do then about fraudulent AS sets and trying to improve this? Well, the best way is ASPA, Autonomous System Provider Authorization. So it's another framework on top of RPKI. We already have ROA, the Route Origin Authorization, where you authorize origination of routes, which only validates the first AS in your AS path. ASPA tries to validate the upstream providers as well. That is currently going through IETF. It's not ready yet, so basically there's no rescue there for you yet. We'll get back to that. So while we're waiting, we need to, well, in Telia we decided we need to monitor what goes on in the internet routing registries regarding our AS numbers and our routes, etc. And we will use various online tools for that, such as IRR Explorer, BGP tools, etc. So ASPA, getting back to that, is exactly specifically targeted against this. This was what I tried to explain. ASPAs will, in short, rather than verify the origin, it will say who are your allowed upstreams, and then the tier 1 provider can check all steps of the AS paths and not just the, today the origin is validated and the origin will be valid or invalid. In the future with ASPA, all AS boundaries that are linked in the AS path will be validated individually, and they can be either valid, invalid, or unknown. But as I said, while we're waiting, what we're doing is monitoring the IRRs. And in BGP tools, for example, basically you look up your AS number and then go to the whois page and you scroll all the way down beyond the very, very long whois entry, and you will see this AS number is actually a member of the following AS sets. And then you can actually click those AS sets, see where are then those AS sets being referenced. And if there's anything here that you don't recognize, I would encourage you to reach out to the people owning those entries in the database. I've tried to do this with most of the Telia entities that we have, and it's a work. Some people actually respond, most don't. But if you follow this chain of reference with all of the AS sets referencing then AS sets referencing other AS sets, in the end referencing your AS number, then you can sort of have an overview of, well, what are the AS sets that someone could try to pass off to a tier 1 provider or any other IP transit provider and be allowed to spoof your AS number. This is of course tedious work to do manually, so as engineers we want some sort of monitoring system to allow you to do that. But when you do that, you find that there are many AS sets in the database that are questionable, to say the least. For example, I have here IIXP peers, well, and some peering in Düsseldorf, I think, but Telia does not peer with anyone in Düsseldorf. And there's a very long path of recursion here that starts with this AS set mentioned here and goes through a lot of different AS sets that are each referencing each other, and then finally coming down to the Telia AS set in the end. Somehow that is being referenced here. And this is the Düsseldorf one. These can just grow to an infinite length in theory, actually. And I'm sure that each and every one of these AS sets are created by someone who has some idea of what they are semantically going to mean. But clearly, something somewhere has gotten lost in the semantics because we are not peering there with this AS number as these guys seems to be suggesting. So I would encourage you to try to use some of these tools, and we use BGP tools, but I'm sure there are others as well. And this would actually, this is a clip from their monitoring page that they provide to us, where this will bring up an alert to our NOG whenever someone actually enters a new AS set in a database somewhere that references us in some recursive form. I would encourage you to do that and come talk to me later if you think this is the first step to a BGP hijack, or if you think that I'm pretty much just overreacting and this is just how the internet works. But so, summing up, I skipped very briefly over ASPA because basically it's not ready yet. But I asked actually Job, who is championing the ASPA efforts in IETF, to just come and quickly tell us, are you ready soon, please? What's the holdup?
So we've been working on this as fast as we can for the last 7 years. ASPA in a standardization organization like IETF is composed of a few components. How do you binary encode this in the RPKI system? So how do we verify the signatures? How do we apply verified information to BGP messages that our routers receive? And how do we get this validated ASPA information into the routers? And it's that last step that we're now in IETF actually working on. My hope is that within a few months, the last T's will be crossed and I's will be dotted, and that portion is finished. So I'd say we're 95% there, but you know, when you go on vacation and you have your children in the back of your car and they're like, "Are we there yet?" You just make shit up as you go. Next slide, please.
So real soon now is what it says, right?
Any time now. So a few more months. And then, and this is really, really critical, ask your vendors. Because the likes of Nokia are telling me, Joe, nobody's asking for ASPA. I'm like, that's not true, Nokia. And they're like,
I'm asking for it.
great. But we need more people to do that. Ask Juniper, ask Cisco, ask Nokia, Arista, because that will greatly drive our ability to enable this in the network in the next 2 or 3 years.
You wanted to talk about it.
Last slide. ASPA is not just a theoretical idea that we've been working on for the last 7 years. There actually is usable open source software out there in the form of OpenBHPD, BERT, Routinator, RPKI client. A lot of work has gone into understanding whether ASPA actually works in real environments, such as IX route servers.
So real soon now. And in the meantime, please monitoring what you have. So monitor what is going on as an operator, as the IETF. Hopefully it will be soon. Questions, Alexei?
So, Alexei Suonen from Finland. Job wanted to play devil's advocate for my presentation, so I'm returning the paper. This is a simple, sort of stupid question to drive.
The session ends at 40 today, just to let you know.
Yeah. So can you go back to the ASPA slide, or actually the one before that, where was the spoofing example with the graph of the AS? Is this one? Yeah. So ASPA will prevent this one, but what if the attacker also spoofs 1299 in between his own AS and spoofed 3301?
You should view ASPA as a means to understand path plausibility. And just like with RPKI route origin validation, the ask towards the community is reject invalid routes. And if the route is not found or valid, then that's not important. ASPA is not BGP-SEC. So the AS path, to some degree, can be forged. But you have to forge plausible paths. And that imposes restrictions on how exactly you can present yourself to the victim of an attack. So formally speaking, ASPA does nothing against AS spoofing. In practice, it will block a number of situations like these just because the subset of plausible paths that can be spoofed is of course smaller than the number of paths that can be spoofed in general without ASPA constraining what would be plausible or not.
I would say, as an operator, 10 or 15 years ago, IETF came with BGP-SEC, and it was perfect, except it was undeployable. So now we have the RPKI setup. We have ROAs that covers maybe 70 or 75% of use cases, and then we have ASPA that covers another maybe 20%. So no, this is not perfect, but if we keep building on top of this RPKI, I think we can sort of stepwise or authorize more and more of the AS path, which will be a lot more helpful than having a perfect setup that no one can deploy.
As to your open question, whether you think this is a prelude to an attack or not, I think it is a definite maybe. We've already seen attacks like this in Canada and Korea years ago. So, and we know this is the modus operandi that, for example, Russians use on, well, all battlefields.
We've seen with RPKI.
Can you introduce yourself?
Hi, I'm Julia from Netherlands. We've seen with RPKI, if you make it really hard to hijack the BGP sessions, they'll go for something softer and easier, like the simple password you used for your RIPE account. If we start rolling this out, do we risk just moving the attack vector and the attack surface to something further down the line that perhaps isn't as secured as we think it is?
Yes. Definitely.
My
And if
next
so,
talk is
what
about
should I be
this
attacking?
topic.
Yes. So the answer to your question is yes. If you put a stronger lock on your front door, yes, they will absolutely try to find a window they can break in through, and then you need to then secure your windows. So you just need to keep adding more and more security, because you know better than anyone, security is never perfect.
The S in networking is for security.
Yes.
So we're already almost 5 minutes over. So thank you, Lasse.
Thank you.